Hello, welcome and a very good evening. Today we got another one of these nice little SMD soldering kits, which is supposed to let you inexpensively learn how to solder SMD components. And as usual, we got the kit. We got our Emil Otto FP002 flux in a syringe, which you definitely should have. We have our flat tip iron here. We have the good leaded solder. We have a 9-volt battery pack thingy to plug a 9-volt battery in, but we will use only 3 volts because I'm not sure, but this is probably 3-volt logic here. So we have a battery pack with these connectors here and 2 1.5-volt batteries. So let's open up the kit and see what's in there. And there's actually, this time, even some explanation, which is very nice. Last time everything was in Chinese on the PCB and there was no explanations. This time it's in Chinese, but at least we have schematics and everything, which is nice. And we can immediately see we have 2 tiny little ICs and the usual packaging, which we already know from our last experiment. Something that is new are these tiny, or no, these are rather large actually, surface mount LEDs. They are white, but I guess they can come in different colors. There's also some of the regular tiny LEDs, which are red, but you can't tell that from just looking at them. They come in different colors as well. At least I hope these are red. The last kit that I soldered from this stuff was red. We have a bunch of resistors here, which are, what does it say here? 102, so that's a 1 and 2, that's a 10 and 2 zeros. That should be 1 kilo ohm. There's also some resistor packs, 4 resistors in one tiny SMD package, some teeny tiny capacitors, which should be the smallest here. Does it actually say what it is? This is a schematic. That is 0603 footprint, it seems. Okay, that's the tiniest ones. Same goes for these resistors, 0603 resistors with a value of 1K each. And some huge resistors, 1206 size resistors with 12K. It should at least be, it's 1, 2, 3. 1, 2 is 12 and 3 zeros, it's 12K. And here are the instructions. Feel free to pause, make a screenshot and translate it, or maybe you can read Chinese. I can't, but it's pretty nice. Everything is labeled here. And the schematics even are on the background. You can also pause here and have a look. So basically one of these things, this here is, I think, a shift register probably. Let me see, these are the big ones. Yes, this should be a shift register, and this is a counter CD4060. So this thing here counts in binary all the LEDs, and then the output goes into the shift register, 3 bits, and it will cycle through all the LEDs. And that's how we notice that everything is fine. The resistor arrays are in series with some of the LEDs, so if you messed up there, the LEDs won't light up. Same goes for the resistors here, for the tiny ones, and the resistors in between the 2 chips. And there's one capacitance flowing over there. The C out goes into the C in, and I guess if you mess up the capacitors, this won't work either. Which is very nice, because then you can check if everything works. Let's heat up the iron. We will start as usual by taking flux, putting it onto all the pads roughly, and in copious amounts. The beep signals that our iron is already done. I'm using 350 degrees Celsius, and I'm not sure how much watt this thing has, but it has something like 60, I think. If you've got a weaker iron, it might be a bit more difficult. The more watt an iron has, the easier it is to heat up the pads, and the quicker you can do the soldering job. Otherwise, the heat gets sucked away by the copper in the PCB or something. And, well, you have to put your soldering iron longer onto the pads, which is not a good thing. It will maybe heat up the components for longer, so always be a bit careful with that. Then we take our spool of solder and we will clean the tip of our iron, of course, and start wiping all the pads with lots of flux and tin, or solder better to say, just like this. So, also make sure to have enough ventilation in your room, because the fumes of the flux are not that good for your lungs. So always keep a window open or get one of these nice ventilation and filtration thingies. Yeah, let's have a look. I put solder on everything. If there's something looking a bit too much, you can wipe on it again. There should be a slight blob with a nice shiny surface. If there isn't, you can just retouch it a bit. Even if you have too little flux, you can add a little bit more. We will start with the resistor arrays, I think, because those are the trickiest ones on this board. The resistor arrays here are actually, the pads are spaced a little bit far from each other, so you have to place them very carefully. And for this task it's actually nice to have some tweezers. So here are some cheap tweezers from a cheap soldering iron, which should be good enough for this task. There's a plastic foil on top of the strip. These strips usually are on reels, which go into the pick and place machine. But of course we do it all manually here. That's what we like to do. And one of the resistors flew off. So make sure this doesn't happen to you. I'll be right back. I'm gonna search for this resistor. I think we got lucky. There's everything in here. I'm gonna zoom in a little bit more. You're probably not gonna see perfectly. I roughly put them on their pads, not perfectly. I'm gonna turn up even more light for me. Won't make much difference to you. However, this would be a trivial task probably with a hot air station, but we're gonna hand solder this. So the trick here will be to heat up one side of the pads while nudging around a thing until it aligns. And this looks good. Then going over the other side, and then I'm gonna alternate and see if it still moves and aligns itself a little bit better. Here, did you see that? Did I? Oh no, I wasn't in shot. Too bad. It made a little jump and aligned itself a little bit better. Now it lost contact again because I heated it up again. So that's the tricky balance. These are pretty sturdy, so you can't easily burn them. so don't fear that you destroy them. And even if you do, I bought 3 kits. You should also buy more than one, just to make sure that you have enough spare parts to get at least one working copy. So I don't particularly like the pads for this thing. Let's have a look. It's not the nicest. Let's see, can we see that? A bit more light over here. Yeah, I think you can see that it is aligned, all the pins are there. And I'm gonna do the other 9 resistor packs now, but you see what the rough idea here is. So this is actually almost the most difficult part in this kit. So no worries, it will get easier. So as you can see, we have 5 kilo ohms over the 5 in series resistors. I'm just probing a few of these lines here. Now I have open line, but I think I missed here. Now I got the pad and it shows 5 kilo ohms. So I would say this is fine. I'm not super happy with my soldering here, but I think, let's try to put more light on here. I think it looks okay. At the moment you see mostly the glare from the flux. It's really bathed in flux. But I think we are fine. Now I would like to do the ICs, because why not? We probably should do the resistors first, but I feel like doing the ICs today. Let's look at this one here. Can we focus on it? You probably can't read it. I can see that it's a CD4060. So that should be the counter, and it goes over here. You have to turn it around a bit. The trick here is either to use a hot air gun as usual, but we don't do that. But to tack down 1 pin on one side and 1 pin on the other side, while making sure that we are aligned correctly. And not to burn the plastics of the case that the AC is packaged in, like I was almost doing here. So 1 leg down. Well, I think it's not very symmetric here, so I'm gonna push it a wee bit more over here, if possible. The problem with pre-tinned pads, like I did, is that there might be too much tin on there, so that they don't want to fall into place like they should. I'm gonna heat this up a bit. Gonna heat up this a bit. And then it's stuck. Now we can heat up all the pads a little bit. Basically just wipe down here. You will see that the solder will flow up the legs a little bit, which is fine. Get it all nice and covered. Turn it around and do the other side. And if there's not enough flux, put some more flux on it. It will help the solder get exactly there where it's supposed to be. I'm even thinking that my tip could use a little bit more solder. So I'm gonna re-tin it a bit. I'm gonna wipe down here to make the legs even shinier. The same for the other side. This way you probably won't end up with any bridged legs, and if there is anything bridging, put more flux on it and wipe it off. That should be very easy to do indeed. So don't fear when there's a bridge between two adjoined legs of the IC. Shouldn't matter. So let's have a quick look. I think this is not my worst job. So let's take the second chip, which is the shift register, and we'll put that here. Always note the orientation of the chip. There's a notch in the print on the PCB and there's a dot on the chip. Same was here, so the dot and the notch have to align. Sometimes the chips have a notch as well, but if no notch is there, then there will be some kind of dot like this. So chips always have an orientation, I would say. Don't mess it up, or you will destroy the chip because the power will go into the wrong pin or make a short circuit or something. Usually the chips will get very hot if you do that and die a very quick death. I think our chip here has a little problem. I think in transit or somewhere else it got a bent leg, which I straightened out. Shouldn't be a big problem. Maybe we will put some more solder than actually needed onto that leg. I'm touching every pin ever so slightly. I could feel the bent pin still going down a bit, so it wasn't straight afterwards. We can gently push on the pins and sort of like nudge them into the solder. And they should get more shiny when you do that, because the solder will flow a bit onto the legs. I'm gonna retouch the other side once more. See, I'm just tipping, not staying with the iron too long, because these chips are a bit temperature sensitive, so be careful with them. I think this is looking quite okay. Next up, we will tackle, what will we tackle now? I'm gonna say we take the big resistors. The big resistors belong here, I think. R1 to R10. When I say big, it's of course relative. As you can see, I placed them roughly in the right spot. If they're not correctly aligned, that doesn't matter. They will float into place in a second. Also get your tweezers ready, because they might start tombstoning, which means they will stick on their end. And also you might have to hold them a bit down when you remove the soldering iron, because everything is sticky with the flux. So now I've already soldered one. However, if you carefully look at this one, it's slightly at an angle, and that's not nice. So I'm gonna alternate between both sides with the iron, and that thing will pop into position very quickly here. Did you see it jump? I did a little wiggle and now it's basically perfect. And I'm gonna do this with the rest, with the other 9. So and that was a rather quick job, and I think they look pretty neat, I would say. They're all pretty flush, they are pretty centered, and I just, well, alternated between both sides and made sure that I didn't pick anything up by accident. So let's do the next smaller batch of resistors down here. Here, I think R21 to R22. That should probably be these ones, because they are the next smaller size. And once more, I put them very roughly in the spot, and I think we'll be fine. We will start soldering them now. Get your tweezers ready and do just the very same technique. By now there should be so much flux on the board that we don't need to reapply. But if yours seems too dry, feel free to put a bit more flux on there. You almost can't have too much flux. Well, probably you can, but the flux will help immensely with the manual soldering. You can also try to swipe parallel at the edge, because the capacitors and the resistors are actually made from some kind of ceramics, so they can take a bit of heat. And it doesn't matter if you touch their sides, not the metal ends. This one here just made a flip, so I'm carefully putting it down correctly again, and it wants to jump away, which I say no, you stay. And this one as well. This one I didn't touch at all, I just swiped next to it, which is also a technique you can try. This one here is at an angle, so let's wrestle it over with the tweezers. And there we go, it's in place. Already got 6 soldered. Doing through-hole components would have been way longer. So although people like to do through-hole often much more than the SMD stuff, if you have lots of components, then SMD, even manual SMD, is so much faster, because you have to clip the leads on the through-hole stuff, etc. So I'm gonna quickly do the rest and stop talking for a while. Here we go. Another array of tiny resistors are soldered. Next up, I would say we take these tiny ones here, the 0603 I guess, and then their cousins, the capacitors, also in 0603 size. So how can you tell them apart? Well, as usual, the capacitors are these brownish with the silver ends, and the resistors are the black ones with the number on them. These are 1K resistors, 10 and 2 zeros. So there we go. The principle here is the same, but they are getting smaller and smaller. So be careful not to lose them. I'm gonna quickly place them on the PCB and do the same technique that we just did with the bigger ones. So this one here wants to stand up. That's what we call tombstoning. But just heat up the one end that it's sticking at, and it will fall over. There we go. This was by far the most trickiest resistors, because there was a little bit not enough flux, and they have a tendency to twist around, these little buggers. So yeah, in the end I was wiping just between two adjacent pairs to heat them up evenly, and they would pull themselves onto the pads, gently nudging them with the tweezers when necessary. So that's what you probably should try as well. These tiny things are definitely better suited for hot air soldering, but they're still manageable. Let's do the capacitors next. They are basically the same. Okay, this was almost even trickier. This middle one here looks a bit wonky, but I think it's good enough. All the others are pretty nicely aligned. The problem here is when you go with the iron in between those, they will heat up the neighbor and it will get pulled off the pad. But I think we should be fine here. And these things are almost as small as a grain of sand. So let's get to the home stretch. We only have the LEDs left. And let's have a look here We're gonna make the smaller ones first. You see the arrow pointing down, all the LEDs are pointing down. And when looking at the LEDs in the package, they have a green bar at one end, at the bottom here, which corresponds to the arrow. On the back side we will also see a symbol, but the green part should be facing in the same direction as the arrow. So there you have it. So here you can see it. Basically it's a T shape, but you can imagine it as an arrow with the this thing here pointing to the side where you want it. If we flip it over, you will see that exactly there is also our little green bar here. That's tiny. So this has to point to the bottom of the PCB. I'll place them and then we start soldering. Let's have a quick look. I think all the green bars are facing this way. So we will start to heat that row up so that we have them stuck in place. Be sure not to heat them too much. The LEDs are a bit more fragile, but they should survive this, I think. So let's go. Okay, one little bugger wanted to go away, but we have them all. They are a tiny bit crooked, so you might want to retouch that, but I don't want to heat them too much. The brown stuff is the flux, which gets a bit burned, which is fine. I think we go to the last component, which are these chunky LEDs. Be careful, they also have polarity and their casing is made from plastic that will melt. Believe me, I tried. However, not all is lost. I will show you one in detail. Come on. So first of all, they have a tiny little notch up here. That's basically the arrow. So this way is the arrow of the diode. And they have metal pads. And you only need to heat up the metal pads. Don't heat up the plastic casing. It will melt. So let's place them. Notch is this way. So let's do it like that. So once you soldered one row, you can twist them around the PCB and solder the other row. Make sure not to touch the plastic, if possible. If something is crooked, you can try to alternate between both sides very quickly. There you saw the jump, and it will align itself much nicer. There you saw another jump. Okay, that jump made it more crooked, but there you go. Yeah, nicely aligned. We're almost done. Last part is the power. Plus is here where the J1 is, minus is down there. So make sure to not swap that. There you go, it's attached. Now, we will clean this with some IPA and an anti-static brush, but first we will test it. So the moment of truth has come. Everything is soldered, there's still a lot of flux on there, which we will clean off in a minute off screen. But yeah, let's plug it in, make sure the polarity is right. And it seems to work. Let's turn off the lights, that you can see a bit better. Here the binary counter works just fine, the shift register works. Lighting up LED 4, 5. However, LED number 6 has a problem. And I measured it off screen. LED 7 and 8 work fine as well. And I trace it back, everything. I retouched all the connections, which you should do as well if you have a problem like this. It turns out that LED 6 is lit up by that tiny little leg that was bent in shipping. So I think the connection to the output line of the chip has broken. That thing is probably defective now, but all the rest is working. I could replace this thing with the chip from the other board, which I might do just to make it perfect. However, I think this is already a great success. This was not our fault. We did everything we could to save this little bugger. But in the end, it was broken. But there you have it. It's a very nice little thing. I would suggest that you try it out as well. It's a very nice thing indeed. I'll put a link to the eBay listing in the description, which might change, of course, in the future. So you can search for yourself as well for these kits. And I think this might make a very nice Easter gift for your loved one, if they so desire. Anyway, and this is it for today. Please share, like, and subscribe as usual. Subscribing helps a lot. And if you want to go above and beyond, feel free to support me on Patreon, Ko-Fi, or via PayPal, so that I can buy more stuff like this and show it off to you and how to learn things with it. So far, that's it, and have a very nice evening, and I hope to see you in the next video.